This is part 2 of section 8.1. We have some properties here, and for this section only, we really have to worry about this. Okay, basically what's going on here is this the square root of a squared. This is a 2, this is an understood 2. If you look here, this is for general root, and notice our index and our exponent are the same. Okay, if you take a square root of something squared, you get the absolute value of that number back. Okay, so let's look at it this way. If I'm taking the square root of -4 squared, okay, well, I need to simplify it under the radical first. So I do -4 squared, and the negative is inside the parentheses, so this is -4 times -4. So I have the square root of 16, and then the square root of 16 is 4. I got the 4 back, but I actually got the absolute value of -4. I had to make it positive. The thing is, you're always going to end up with a positive number under here. And then when you take the square root of a positive number, you're going to get a positive answer. Okay? Here, the same basic thing is happening. Except if this is an even index, which this is a special case of, if this is an even index, you're going to get the absolute value back. And if it's an odd index, you don't have to worry about the absolute value. Why? Let's look at it. Okay, if I'm looking at, say, the third root of -2 cubed. Okay, so I have an odd index. So if I'm following this pattern, I should get -2 as my answer and not have to worry about absolute values. Well, what is -2 cubed? Well, that's going to be -8. And then you can use your calculator. The cube root of -8 is -2. So basically, even indices make the negative go away. So we have to make sure we're dealing with the absolute value. Odd indices, you can have a negative. Now, why do I say we only have to worry about that in this section? That's because after this section, we are told that our variables are positive numbers, always. And if we're always plugging in a positive number, then we don't have to worry about absolute values because we're never going to get a negative that we need to take the absolute value of, okay? I'm teaching these because I can't avoid them on the homework. I'm not going to put them on the test, but I will show you how they work so we can get through the homework, okay? And then the basic idea is going to apply after this, but you're not going to have to worry about absolute values. Okay, so let's look at the 6th root of -4 to the 6th power. Now, I've written down the properties on an index card so we can refer to them easily. What we have here is we have the same index here and here. It's a 6. And 6 is an even number, so I need to use the absolute value of the number in here. So this is going to equal the absolute value of -4, which is +4. You could enter this the same way in your calculator. Let's clear that. So I have a 6th root. Use your parentheses, -4 raised to the 6th power, and I get +4. You have to enter it exactly as it is written. But of course, this does not help you when you're dealing with variables. Your calculator can't do that. Okay, so we've just used this property right at the top. Okay, so let's try this one. The 5th root of 1/32. Now, you might get panicky because, ooh, it's a fraction. But I'm going to give you a property that we technically don't learn until a later section. If you have a fraction under a root, you are allowed to split it up into the root of the top over the root of the bottom. Okay? Well, any root of 1 is 1 because you can multiply 1 times itself however many times you want to, and you're still going to get 1. Okay? Now, the 5th root of 32 is 2. So this answer is 1/2. Okay? All right, so let's calculate a negative on the outside, the cube root of x cubed. Well, first of all, if we've got a negative on the outside, we bring the negative over. Okay? Now I'm going to apply this property. I have the same index here and here. So these match, so I can use this property. 3 is an odd number, so I only have to worry about the base. I do not have to worry about absolute values. So this negative is this negative, but then the cube root of x cubed is x without the absolute value. Okay, so let's look at the fourth root of x to the 12th power. Now there's a property from chapter 5 that we need to remember, and that is a power raised to a power, you multiply those together. Okay, I can rewrite x to the 12th as something to the 4th power because 12 is divisible by 4. I can rewrite this as the 4th root of x cubed to the 4th power. This property says a power raised to a power, you can multiply them together, and that does give me 12, so these are the same value. But now I have the same value here and here. This is more complicated than what we have been dealing with, but it works the same way. I have an even index, so I need the absolute value of what is inside. So this is the absolute value of x cubed. And that will be your answer. And we need to keep the absolute values because if x happens to be a negative number, when we raise it to the 3rd power, it will still be a negative number. Okay? So let's do something similar here. The 6th root of x to the 24th. Okay, well, 24 is divisible by 6, so I can rewrite this as a power of 6. So this is the 6th root of x to the 4th to the 6th. Okay, 6 times 4 is 24, so this is the same. Now I have the same index and exponent. These are even, so I need to use absolute values. So this is equal to the absolute value of x to the 4th. Here, we had to keep the absolute value because if x is a negative number, when we raise it to an odd power, it's still a negative. And we need a positive answer, so we have to keep the absolute values around. But here, we can drop the absolute values. And the reason for that is if you take any negative number and you raise it to the 4th power, you're going to get a positive answer. So this is automatically positive. Having absolute values around it would be redundant. Okay, and again, I want to stress this is for this section only. After this section, we don't have to worry about the absolute values. Okay, so one more. I want to find the negative square root of x squared. A negative on the outside, you bring over the negative. Now this is an understood 2, so we have the same index and exponent if you want to think of it this way, but we definitely have this already written down as a special case. The square root of a squared is the absolute value of a. So you put a in absolute values and a negative on the outside. And that's it for this section.